All right, here we are starting Unit 4, and I'm starting that unit with learning about different properties of exponents. So we're going to do lesson 19.1 today. So our learning targets are we are going to be able to develop basic exponent properties, and we're going to be able to simplify expressions involving exponents. So we're just going to go through this whole lesson. So it says an iceberg is a large piece of freshwater ice that has broken off from a glacier or ice shelf and is floating in open sea water. Icebergs are classified by size. The smallest iceberg is known or is called a growler. A growler was found floating in the ocean just off the shore of Greenland. Its volume above the water was approximately 27 cubic meters. So going to number 1, it says 2 icebergs float near this growler. One of the iceberg's volume is 3 to the 4th power times greater than the growler. And the second iceberg's volume is 2 to the 8th power times greater than the growler. Which iceberg has a larger volume? So remembering how exponents work. So 3 to the 4th doesn't tell me 3 times 4. What it really tells me is 3 times itself 4 times. So 3 times 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So the first iceberg's volume is 81. And then the second iceberg is 2 to the 8th power, which is 2 times 2 times 2, 8 times. 2 times 2, that's 6 times 2 times 2. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2, which is 128, times 2, which is 256. So the second volume is 256 cubic meters. So the second iceberg has a more great volume than the other iceberg. So number 2 says, what is the meaning of 3 to the 4th and 3 to the 8th? And why do you think exponents are used in writing numbers? Well, the meaning of 3 to the 4th is 3 times itself 4 times. And 2 to the 8th is 2 times 2 to the 8th powers 8 times. So the reason why we use exponents when writing numbers is it is a simpler way of writing out pretty long multiplication problems with the same number. So the expression 3, 4 is the power. The base is 3 and the exponent's 4. And then the term power may also refer to the exponent. So number 3 says, suppose the original growler's volume underwater is 9 times the volume of above. How much of its ice is below the surface? Sorry. So 9 times the volume of above, so it'd be 27. 27 times 9. Come on. Which is 243 cubic meters. And this is because the volume above the ice was 27, and 9 times that is 243. So it says, write your solution to item 3 using powers. Complete the equation below. Write the missing terms as a power of 3. So the volume of the water was 27. Above water was 27, which could be written as 3 times 3 times 3. So that'd be 3 to the 3rd power. Times 9 times amount. Well, 9 can be written as 3 times 3. So this would be 3 squared, and this would be 3 to the 5th power to get 243. So it says, look at the equation you completed in item 4. What relationship do you notice between the exponents on the left side of the equation and the exponents on the right? So what are we noticing between the 3 power, the 3rd to the 3rd power to the 2nd power, and then it equaling 3 to the 5th power? And we'll explore that. So it says, use the table below to help verify the pattern we noticed in item 5. Maybe you came up with one. First, write each product in the table in expanded form, then express the product as a single power given the base. The first one has been done for us. So we have 2 times 2 to the second power times 2 to the fourth. Well, 2 to the second is the 2 times 2 times 2 to the fourth. So times 2 times 2 times 2 times 2. And if I count up how many times I'm multiplying 2, it's 1, 2, 3, 4, 5, 6. So 6, 2 to the sixth power. And we can see this with 5 to the third times 5 to the second. So 5 times 5 would be 5 to the third times 5 to the second, which is 5 times 5. So I'm multiplying 5 times, so that would be 5 to the fifth. Let's also see this with my x's. So we have x to the fourth, so that would be x times x times x times x times x to the seventh times, I'm going to run out of x, times x, times x, times x, times x, times x, times x. So that would be x to the 11th. Oops. X to the 11th power. And then let's just think about what would a to the 6th times a to the second. Well, if I could write it all out, but I bet you if it's following the same pattern, this is going to be a to the 8th. So expressing regularity in repeated reasoning, based on the pattern we observed in the table in item 6, write the missing exponents in the box below to complete the product of powers property for exponents. So if I have a to the m times a to the n, well, to figure out my simplified, it would be a to the m plus n. We add those two exponents together. Now, it's important to know that that is only when they have the same base. So since they're both a as the base, this is why we can add their exponents together. So use the product of powers property to rewrite x to the 3/4 times x to the 5/4. So this would be x to the 3/4 plus 5/4. Adding fractions, 3 plus 5 is 8. This would be x to the 8/4 or x squared. So it says the density of an iceberg is determined by dividing its mass by its volume. Suppose we wanted to compute the density. Well, we would just divide that by 59,049 by 81. And you could do that, but for the sake of time of this video, it's 729. And we're actually just going to jump to number 12, where we're looking at a different property. So it says, use the table to help verify patterns we notice in item 11. First, write each quotient in the table below in expanded form, then express the quotient as a single power given the base. The first one has been done for us. So we have 2 to the 5th divided by 2 to the 2nd. Well, anything divided by itself is 1. So my 2 over 2's cancel out. 2 over 2 cancel out. So all I have left is 2 to the 3rd. And we can see this with my next one. If I have 5 to the 8th divided by 5 to the 6th, 5 times 5 times 5 times 5 times 5 times 5. That's 6 times 5 times 5 over 5 to the 6th. So 5 times 5 times 5 times 5 times 5 times 5. And that will be, anything divided by itself is 1. So cancel, 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 cancel. So what I have left is 5 to the 2nd power. I can do this with my variables too. A times A times A to be A to the 3rd times A. Anything divided by itself is 1. So we're left with A squared. Same with my x's. X times X times X times X times X times X times X over X times X times X. Anything divided by itself is 1, so we're left with X to the 4th. So what's happening between my exponents in my division is that we're subtracting them. So it says, based on the pattern we observed in item 12, write the missing exponent in the box below to complete the quotient of powers property. So this would be m to m minus n. So then it says use the quotient of powers property to rewrite 11 a to the 11 over 3 divided by a to the 2 over 3 as a single power. So this would be a to the 11 thirds minus 2 thirds, which would be a to the 9 thirds, which is equal to a to the third. I'm going to stop here because this is the basis for my two properties, and then make sure you have those notes written down as well, and then I will come back and do a more complicated problem for part 2.